Think of subtraction not as taking things away, but as measuring the physical space between 2 points. If we stand both of these figures on identical blocks, their absolute height changes, but the gap between them stays exactly the same. This is a standard number line, showing evenly spaced increments. Whether you measure the space between 2 and 4 or 8 and 10, the physical distance is identical. Shifting two numerical values up or down by the exact same amount preserves the gap between them. This is the constant difference strategy, and it allows you to simplify a subtraction problem without changing the result. Let's apply this to 70 minus 59. The rule here is simple. Always look at the second number, the subtrahend, and figure out how to turn it into a clean, friendly multiple of 10. 59 is 1 unit away from 60, so we add 1 to 59. To maintain our constant distance, we also add 1 to 70, landing on 71. Our equation has now become 71 minus 60. The distance is 11. By shifting the entire problem to a friendly baseline, you bypass the friction of traditional mental borrowing. Try to solve 64 minus 47 in your head using traditional column math. You have to borrow a 1, hold a 14 in your working memory, subtract 7, then remember that the 6 is now a 5. It is a process that often leads to dropped numbers and errors. Let's use the constant difference strategy instead. Add 3 to 47 to get 50. Add 3 to 64 to get 67. 67 minus 50 is 17. There is a common trap here. Because of how we learn addition, it is easy to assume that if you add 3 to one side, you must subtract 3 from the other to keep things balanced. If you add 3 to the bottom number but subtract 3 from the top, you move the points in opposite directions. You have changed the distance between them, and the resulting answer is no longer linked to your original problem. Subtraction demands absolute symmetry. Whatever operation you apply to the bottom number must be identically applied to the top number to preserve the gap. Making a number friendly doesn't always mean rounding up. Let's look at 51 minus 26. Here, it is easier to shift backwards. Subtract 1 from 26 to reach 25. Subtract 1 from 51 to reach 50. 25 is a highly compatible number because it mimics the values we use when counting currency. 50 minus 25 is exactly 25. Now you try. Look at 102 minus 76. Find a way to make 76 friendly, then apply that same shift to 102. Adding 4 to 76 reaches 80. Adding 4 to 102 reaches 106. 106 minus 80 resolves to 26. Having the flexibility to shift either forward or backward gives you control over the complexity of the calculation. This strategy scales to larger numbers. Take 500 minus 289. Target the 289. Adding 11 bridges the gap to a perfect 300. To keep the distance constant, add 11 to the 500 to reach 511. 511 minus 300 leaves us with 211. Here is the 3-step process. Step 1. Target the second number. Step 2. Shift both numbers in the exact same direction. Step 3. Solve the simplified distance. Step 2 ensures the gap stays the same. Moving numbers differently changes the original problem. Mastering constant difference allows you to rewrite subtraction problems into versions that require no mental borrowing. When you treat numbers as points on a line, multi-digit subtraction becomes a matter of simple logic rather than a test of memory.